my name is Vinícius. I'm a field engineer for Pivotal, but before joining Pivotal, I was actually working at Warner Music Group. And there I was the lead architect for the engineering team. I worked with Brian McLean, and if you guys saw his presentation prior to this, I was his counterpart on the development team. So this presentation is about some things that I've learned when I was there and trying to get our applications into production, right? And what does it really mean for you to develop into Cloud Foundry? To give you a little bit more about my background, I've been working with Java for the past 12 years. And I worked from startups to large corporations like Ericsson. I've been an architect, an engineer, product owner, and Scrum Master. But at the essence, I like to think myself as I'm a developer. And that's the reason I love Cloud Foundry. I first heard about Cloud Foundry back in 2011. And since then, when I look into Cloud Foundry, I say, hey, this thing is awesome, right? This thing can actually make my life easier. And I was blessed that I was part of Warner Music when they started their journey into actually getting Cloud Foundry as the platform of choice. And to me, when I look into Cloud Foundry, I see this, right? If you're a developer, you get Cloud Foundry, it's your super power up. But in reality, and someone already made this joke before myself, with great powers comes great responsibility, but it's true, right? What Cloud Foundry will do with your team, if you're an enterprise architect and you want to start using Cloud Foundry as a platform, it raises the bar, right? Because you get all these neat, cool things that you guys have been hearing about, which is self-healing, right? HA, push of an application in one line of code. So for you, developer out there and architect, it means that you have to raise your bar. Now, you don't have that excuse when your boss calls you and say, hey, why we have so many problems in your code? And you say, well, I don't have time to do that because I'm worrying about infrastructure, right? You really need to start pushing yourself harder. And the challenges that we faced when going to Cloud Foundry, one of the first of them was that in large distributed systems, the failure actually is a norm. It's not an exception. Now, the Hadoop guys know this quite well. Data grid guys know that quite well. But if you're trying to embrace the microservice architecture, that's going to become your norm as well. And again, Cloud Foundry is a reliable platform. It has HA and self-healing. But the question is, does your code supports that? Are you ready for that type of things, right? The next thing is you give the developer a great experience to push applications. You have a nice console to check your services and binding services. They'll come back to you and say, I also want a better experience of my APIs or the APIs you're providing to me, right? And how can you enforce security and access control of your endpoints? The service discovery, right? And how can you avoid duplication? And guys, I know a lot of those things here, they are recurring topics in our industry, but one thing I can tell you is everyone has duplication of code in their companies. That's a norm. Now, if you have that with your developers taking weeks or months to push applications, how much duplication do you think you can have when they can push applications in a matter of hours, right? So if you don't start tackling this problem at the very beginning, it's going to come back and haunt you, right? So I'm going to start talking first about the experience, right? And I'm assuming here we're building REST services, just for the sake of this presentation, right? So if you're really building REST services, right, it means that you're using curl a lot to consume your applications. Your developers are going to come back to you and say, hey, why can't you give me this, right, which is an API explorer? Like Foursquare has it. Twitter has it. I mean, your platform has that. I can have a nice console. Why can't I consume my services like this? So it actually turns out that you can. And you can use something called Swagger. So embracing Swagger was one of our initial thoughts. You can have a nice UI to consume your endpoints. Swagger is an API description for REST services, but it also has jQuery plugins, right? So that was the first step. It's okay, I give you an endpoint, I give you an API to consume. You go to your browser, and you can actually use it. It makes much nicer experience for developers to start consuming the services you're building in your infrastructure. And now we're talking about services, right? If I could take a constellation and mimic services, this is what I pretty much can say that any corporation has those days. You have these clusters, right, where they're probably the core business services, and you know about them, and they are documented, people know what they're doing. But what about these guys here? Who the hell are them, right? And every company has that. And yesterday, I was talking to two friends of mine, and they were discussing about the legacy. And I said, hey, we have so much legacy in our company that I don't know who is using those services. I might as well, turn off the switch of some machines, wait a couple of weeks, and see what happens, right? And guys, you're starting a new landscape, right? You're starting with a PaaS. You don't want to repeat the same errors in the past. You want to make sure that you have all those things, documented and where they're stored. Now, Cloud Foundry gives you part of that when you're doing the application deployment and the console, but really what each service is, you need a service registry, right? And then that was the next thing that we had to build. So I understand that Cloud Foundry supports, has a service registry, actually. Service broker is a service registry. But here I'm talking more about service registering in the sense of a REST service registry, okay? So we start with something in a tree architecture. You have services, instances, and API endpoints. And for each endpoint, you add some metadata. I got inspired actually by Apache Curator. They have a nice service discovery for Zookeeper. So if we're talking about the API, Swagger has a convention that there's an endpoint /API docs that describes your endpoints. The next thing is you do have some endpoints there, like get users or put a user by ID. Now, that's where things start getting interesting. If you can start putting security metadata for your services there, where you say, okay, for the get users, for a given client ID, I want to allow a group of set of rules to access that endpoint. And note when I talk about client ID, I'm really talking about OAuth client ID, right? I'm going to touch the UA part in the short term. But if you're really thinking about building services that are going to be consumed by multiple applications, they might have different roles per application. You want to store this here and not in your code. You might add some UI metadata, right? I mean, if you're really building widgets, reusable widgets, you might need some hints on how you want to present that, given they're consuming a service. Quality of services, right? You might want to be limiting your API calls and billing as well. So all this information, and you can do whatever you want here. It depends on your corporation, but you do have a nice structured service registry where you can count on having all the services and the metadata associated in one place. Now, building this should be pretty simple. Pick a database of your choice, and you write it, you have it. The next part is how do you discover? How you make discovery possible. So you guys might haven't seen this slide before. It's a short version. So let's say that I push an app, it's on my DEA now, it's ready for action. One approach would be make your application go to the service registry and say, hey, I'm here, you can grab my metadata, right? But this actually leads to a problem. What if a developer forgets to call the registry, right? I mean, binding the registry should be easy. It can be just a custom user-provided service in Cloud Foundry. So another approach could be make your registry calls the Cloud Controller. There's an experimental API for events, and one of the events is app create. So once an application gets created, your registry go back to your application and say, okay, now give me back the metadata. Now your registry is populated with all the information, and you have the registry part. So we have the registry, we have a nice API description. How can you actually enforce that those things work, okay? There's tons of ways of doing that, right? if you're just doing Java code, you could just bundle a jar with your service and use that information. So for example, you use Spring Security for the security part. But if your services are built in multiple languages, not only Java, right? One idea is to have a service proxy, right? And a service proxy is just an HTTP proxy. It turns out to be a Netty pipeline. So Netty is for those who doesn't know who Netty is this fantastic NIO project that a lot of cool things are built on top of. Reactor TCP, Elasticsearch, they all rely on Netty. It's pretty simple architecture, right? So the user sends a request, right? The proxy will intercept that, get the metadata for that endpoint. It will validate the credentials. It goes to UA and say, okay, check this token. What does this token have? Can you just use, and the token that comes back from UA will have credentials for that specific user. It then applies some other filterings on the chain and finally calls the user service, right? User service will say, okay, here's the payload back. It sends back the payload. And what it could do as well, the first handler is a data filter, right? And the data filter, all it does is, I know who you are, I know what roles you have, you cannot see one of the fields. So I'm going to filter that out, and I'm going to send the data back to you. So now you also have a data security in your platform. There's many ways of doing that. This is one of them. You could also try to change the query on the fly. I'm not a particular fan of that because you have to understand a lot of parsers, and bear in mind that if you have multiple data stores, you have to rewrite your query on different data store providers. The next lesson was security, and I don't want to dive too much in security because it's a huge topic, but do not use LDAP for authorization. And the lesson is corporate LDAPs can be very polluted. So do authentication on LDAP or any SSO appliance you might have. And I'm talking about UA here being your SSO platform. But move the authorization part back maybe to UA, maybe to a separate database. Because now you have this fantastic platform where you can push code in a matter of seconds. If you rely on LDAP, it means that you have to open a ticket again, request a group, take some vacations, come back, and then you might have your group. So you push your app fast, you don't have the group and LDAP in the same speed. To enforce security to go all the way through all the services, and we're talking about microservices here, we're going to have a lot of services all over the place, make sure that you pass the token along, right? So each service that you have must get the token and propagate to the next one. So there's a pseudocode here that doesn't really work, but a simple example if you use Spring Security is if you go to the security context holder, you get the context, you get the token from the call, and then you just pass it along as a header to the next client that makes a REST call. Right? And that is pretty much what I have to talk about security because that's a huge topic, and I don't want to dive in this. I don't have time and the expertise to talk into that. But you guys probably were in the Madenstein microservices. Everyone was there actually, right? A talk, and that was fantastic. But there's the dark side of microservice, right? And then there's no, if you play Portal, there's no cake. And what we found out is multiple remote calls that you're going to start having on in your architecture, and entity relationships. That one hurts, and it hurt really bad, actually. So 2 weeks ago, I was reading an article by this guy here. I don't know, Chris Richardson, if you ever heard about him. If you know the Cloud Foundry history, you probably heard about him. So he wrote us an article about microservices, and he was talking about how a solution on solving some of those problems. And I was in joy when I read that, because hey, that's what's exactly where we're heading to, right? I mean, so I wasn't going crazy or something. And when you're looking in the architecture for microservices, you can see something like this. It might look like this. At the bottom layer, you have data services, and data services are as close as you can get to CRUD operations. Core services are services that are complete agnostic of your business. It could be a push notification service. It could be an audit service or a profile service. You move up, you have business services. Those are tighter to your business units. And then finally, an application orchestrating all that. And if you can notice, the number of calls are just increasing as you go down, right? So it means that the response time will go up, right? So you have to be prepared for that. And how do you deal with that? So how I dealt with that is you launch an application, and the application is built on Node.js as a front end, and the back end is complete Java, and you're just sitting waiting for the page to render. And you're wondering what went wrong. I mean, I'm using Node, right? It was supposed to be fast. You open the code, and you see something like this, right? Every single invocation of the services, they are just sequential. So you're paying a penalty of the remote invocation call. But you shouldn't be writing code like this, right? Now, just a message to myself here, I'm not on Scala Days, I'm on CF Summit, but you should be writing code like this, right? If you really want to embrace, reactive and making parallel execution calls, we made a choice where, hey, what if we write code in Scala? I mean, it doesn't have to be Scala. You can actually write code and compose features in Java and just live by the callback nightmare. It's up to you. But evaluating some choices, right, that what we have out there, there's a bunch of frameworks you can think about it, right? There's Akka, RX, Reactor, and Vertex. And they all kind of solve the same problem, right? The idea is I want to have parallel execution, and I don't want to pay the penalty for distributed calls. It just turns out that Akka had a nice feature built in that you guys probably heard about it, and it's a circuit breaker, right? So not only the actor model solved the parallelism problem we had in composing remote calls, it came with a nice circuit breaker as well. And it works with Java. Being a huge Java shop, there's no need for you to switch to Scala, actually. So that was one of our thoughts when moving to Scala. If you look into the next problem, right, it's the traditional web application. And it doesn't matter if you're talking about ERs or WARs. As a developers, we are used to this. This has been built in our DNAs for almost a decade now. This is how we do things. And what I want to highlight is how Hibernate, handles entity relationships. So you're used to have Hibernate to propagate cascading operations for you, and they happen in the same JVM. You move into a microservice architecture. How can you make those things work? And then, to me, it's what I'm calling the ripple effect of entity relationships. Your data services, when you change one service and it's starting propagating all the changes to different related entities. And here I'm talking about resources, okay? Those are at the bottom layer, the data services layer. At the top layer, you solve by using Vertex or Akka or Reactor. You choose one of those frameworks. But at the bottom layer, what we decide to do is, hey, why don't we go event-driven, right? There's a nice architecture for that, and there's an awesome product called RabbitMQ. So we just embrace the message-oriented pattern and say, instead of having to tell the others, why don't I just propagate an event, and who else is interested in that, they can take care of themselves. And I stopped blocking the caller. So the caller is never blocked anymore, right? So we got a bit of agility there. But if you're really serious about exposing your services to the external world, it might happen that you don't want to expose the AMQP protocol. A few things that could be done is you can have server-sent events. So if you have a nice server that behaves nice with an I/O, doesn't block by threads, and it's okay with long polling, you can publish your events on the web for external entities. You might have partners that want to be listening for events or for entities as well. Or you can embrace the webhooks idea, right? Just like GitHub. And there's a very nice project called PubSub HubBub. Yeah, I always want to say that in public. this project is by Google. It's a webhooks implementation. It tells you how to build, brokers for webhooks and so. And finally, but last but not least, was the whole problem of polyglot persistence, right? So everyone is polyglot when it comes to persistence these days. So traditionally, what you would do is you have your service, and it has a bunch of repositories, Spring Data repos. And don't take me wrong, I love Spring Data. But what's happening here is, if it turns out that you need an extra type of repository, and believe me, when you go into the NoSQL world, that again becomes a norm, right? You start adding everything on Cassandra, and then one day you realize that, hey, my developers are doing relationships in Cassandra, and all the queries are taking too long. So why don't I put my relationships on a graph database? And there's a nice pattern out there that people use is Solandra, right? They combine Solar with Cassandra. But you might be doing Elasticsearch. So those things will pop up. You don't want to be in the business of every time a new storage engine pops up, you have to open your services and add the repositories there. So again, same concept of event-driven architectures, right? Persistence is no longer done by the data service, right? And I think that we've just created the nano service, where we got a microservice and we split it over smaller sets. Services just put into the data pipeline a JSON request, and JSON is as good as it gets. Yesterday, Dave McCrory gave a nice presentation on the future of PaaS and data, and he was talking about how JSON might be the good solution for a universal format for storage. Each one of those implementations, Redis, Neo4j, or Elasticsearch, or your Hadoop data lake, they'll know how to, that data make it fit, right? It knows how to, fit the square in the octagon. But you might need a few more information. And this approach, it actually turns to be nice on another facet. So different providers, they offer different SLAs, right? So Redis, we all know Redis is blazing fast, right? But Neo4j might not be that as fast as they advertise. I'm not saying that, but you might have, you may not have a fast engine there. And with this, you can have a different number of instances of those services to keep up with the throughput of your messages, right? So I can have only one instance for Redis because it's too fast, but I might need 3 or 4 instances for Neo4j to handle the traffic that is coming, right? So I think that it was one of the last lessons learned when there was a lot of things. One thing I can tell you guys is if you're embracing Cloud Foundry, if you're looking for a PaaS, you have a lot of things to do to raise your game, start thinking a little bit different on how you deploy your architecture. I really think that this is the first time we're going to get service-oriented architecture right without having to spend $500 million in tooling. And I think that's it. I'm going to thank you guys, and just welcome to the next level. That's pretty much what this is all about. So.